we have come to the last part of these periodic trends, and we will be talking about this electron gain energy. Now try to understand this clearly. This is different from the electronegativity. So this is the energy change that occurs when an electron is added to a gaseous atom. For most atoms, energy is released when an electron is added. So actually you can think of this and you can see we can write the electronic configuration for chlorine. So which is 1s2, 2s2, 2p6, 3s2, 3p5. When it comes for the chloride ion, so we can write 1s2, 2s2, 2p6, 3s2 and 3p6. So one electron has been added in excess when it comes for this chloride ion. So, and we are saying that energy is released. So actually what happens, the chlorine is, having a configuration 3s2, 3p5, which is, more closer to this 3s2, 3p6 electronic configuration if an electron is added as in chloride ion. So which means that is something that chlorine would prefer. It's like the chlorine likes to get stable by taking up one electron in excess. So that the chlorine has obtained this stable electronic configuration, because 3s2, 3p6 means the third main energy level, the p subshell and the s subshell entirely filled. So which means something where the chlorine likes has happened. Now this is, you can think similar to the bond formation. Now later on the enthalpy lesson also you will learn about this, the bond formation. So let's consider, let's say there is some reaction taking place with A and B, two atoms, let's say. So then if there is a bond formation, you will learn that there is a release of energy. So likewise, so that's something favorable for these A and B atoms. So there is a release of energy. So here also something similar to that is happening. So usually the electron gain energy is negative, or energy is released. So because the chlorine has a higher affinity, now we will be using that term as well, electron affinity. So the change in energy when the anion of the element loses an electron in the gaseous phase. So now you might find this a bit confusing, but I have indicated this from your resource book. So it says when an anion of an element like chloride, anion of an element, when it releases an electron, so the change in energy. So it is quite opposite of the electron gain energy. So electron gain energy, it's the taking up of the electron. It's gaining an electron and forming the negatively charged ion, whereas in electron affinity, it's the other way around. So when it loses an electron, so this chlorine actually likes to take electrons because it can attain the stable electronic configuration. So which means it has higher electron affinity. It has higher electron affinity. Since it has higher electron affinity, the electron gain energy, or the energy which is released, would be high, because negative charge, this negative sign always shows you that energy is given off. So please bear that in mind. So I hope you get the point. So I will explain this once more. So I will explain this once more. Now, electron gain energy. When an electron is taken up, energy is given out. So this is like the bond formation also, energy is given out. So when an electron is accommodated in an atom, there is kind of an interaction formed. So energy is released. So that is electron gain energy. So energy change that occurs when an electron is added to a gaseous atom. So for most atoms like to take electrons and get stable electronic configuration. The next we will be discussing about this electron affinity. So electron affinity tells you that the electron gain, it's the opposite of electron gain. So that means the energy change that happens when an anion loses an electron. So an ion loses an electron, so Cl minus. When it loses an electron, it can form chlorine gaseous atom and electron. So that is known as the electron affinity. So, and you can see if the chlorine has a higher electron affinity, it will release a large amount of energy. So what does this negative sign tells you? It tells you that energy is released, nothing else. The negative sign tells you that energy is released. So that's why it is equal to the electron gain energy. When an electron is gained, the amount of energy released. So it's more negative means more energy is released. It's not like what you learn in the number line. Now, for example, in the number line what you learn, you would say 0, 1, 2, 3 likewise. Minus 1, minus 2 and minus 3. So according to this number line, if it is minus 3, you would say this value is less compared to minus 1. That is according to the mathematics what you learn. But in here it's different. So here you are not going to say that the more negative the value is, less electron gain. This negative sign tells you it's release of energy. So don't compare these two and say so more negative energy, or when a higher negative value means it's smaller. That's wrong. That idea is wrong. Okay, I hope you get the point. So the negative sign tells you that the energy is released. So always consider only the magnitude, not the sign. So higher the electron affinity, higher energy is released. So I hope you understand about this electron affinity and electron gain energy. So I hope you understand about this electron affinity and electron gain energy. Now let's move to the next one. So again this tells you across a period what happens. The size of atoms decrease. So these are the things that happen. The size of atoms decrease in a period, so the attraction increases. More attraction for the electron, more energy is released. So the electron affinity increases. So the affinity, so that value become more positive because it increased. But the energy released is high, more energy is released. So gain energy become more negative or higher negative value, more energy released. So I hope you understand that. And next we will look at down the group, the size of atoms increase. With the increase in the size of atom, shielding effect increase. So poor attraction for the incoming electron. So less energy is released out. So the atom is not interested in taking up an electron. So less energy. So the electron affinity is less. So less positive value for electron affinity. So the less energy or less negative down the group, less energy is released. I hope you understand about these variations as well, and you are supposed to apply these information to a given situation. Now, let's look at one example, but there is some kind of a difference. Now, usually we said the electron gain energies are supposed to be negative values, but here you can see positive values for nitrogen and beryllium. So let's see why. Now, nitrogen, if you consider the electronic configuration, it's 1s2, 2s2, and 2p3. And beryllium, it's 1s2, 2s2. Now here we are talking about taking an electron to a neutral atom. Now as you can see, 2p3 electronic configuration, it's half-filled electronic configuration of the p subshell. So this is half-filled. So which means it has less tendency, or it has less preference to take up an electron and form N minus ion. So that's why the energy is positive. That means this is more stable. So to take up an electron, we should provide energy from outside. It's like in a certain classroom, if the classroom is, accommodated with the sufficient number of students, if there is another student coming in, just like this electron, the rest of the students may not like it because they will run short of space. So there is a kind of a barrier. So therefore, we need to put some energy, or we need to tell the students, okay, you have to accommodate this child, otherwise it's something like you have to put more effort to accommodate that child. So likewise, nitrogen is more stable. It's happy with the electronic configuration to input another electron. We should provide energy from outside. That's why it's positive. And with respect to beryllium also, you can see it's 2s2, which is a stable electronic configuration because it's completely filled S configuration, and S configuration is which is more closer to the nucleus. So for that also, if you are going to input one electron, so you need to put some energy to input that electron because this is also stable. So beryllium is also like a classroom which is accommodated with maximum number of students, or which is more stable. And when there is another student coming in, there will be a resistance. So therefore, to overcome that, we have to provide energy. We have to make them understand that you should give space for another student. So likewise, when an incoming electron is added, more energy should be provided.